Hi everybody, welcome to How to Solve a Computer series. This session is about writing algorithm for sine function computation. First let us see what is sine function computation. Sine function, that is sine of x, can be written as x by 1 factorial minus x cube by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial. So it is an infinite series expansion. So let us understand, before writing the logic or the algorithm, some observations from this series. First we will see that numerator powers and the denominator factorials all are following the odd sequence 1, 3, 5, 7. So in general, the term in the sequence can be expressed as x power I by I factorial, where I you can write it as 1, 3, 5, 7. And we see that sine is alternating in a successive terms. First term is positive, next term is negative, third term is positive, fourth term is negative, and so on. Now, we need to observe the relation between the terms. See, any sequence will definitely have a relation. So, let us observe this. X cube by 3 factorial can be written as x squared by 3 into 2 into x power 1 by 1 factorial, where this is previous term. Okay, we get the next term by finding x squared by 3 into 2 into previous term. The same occurs in x power 5 by factorial. 5 factorial also x squared by 5 into 4 into x cube by 3 factorial. So we expand and we find this relation that x squared x power 7 by 7 factorial also has the relation like x squared by 7 into 6 into x power 5 by 5 factorial, which is the previous term. So we denote these powers as I. Okay, so I told you we can represent using a variable I both the denominator as well as the numerator. So now in general, how to generalize this relation means x squared is very much common, and you can write this as I into I minus 1. As you can see, I is equal to 3 means it is coming as 3 into 2. I is equal to 5 means 5 into 4. I is equal to 7 means 7 into 6. So you can generalize this, and this term, whatever you see, is a previous term. So we can write as, so this is the common pattern we find in this sequence, and we generalize this as x squared divided by I into I minus 1, and we can write like current ith term is equal to x squared by I into I minus 1 into previous term. Now it is an infinite sequence, so when do we terminate? So we need to decide one error level. So acceptable error level could be 0.00001. If you can also increase this level, if you increase the level, then the accuracy will get improved. So now we'll dive into the logic. We'll represent all the observations here. What is logic? First you need to tell what is your input. So the input here is you need to tell x. But this x has a limitation. This x value could be between -1 and 1. And process. So what are the variables which you are going to use? So we need a variable to hold the summation of the series. So we'll use that variable as sum, and we need to initialize this sum to the first term. What is your first term? That is x. So sum is equal to x. Then we use a variable to refer the terms in the sequence. So let it be term. And we'll initialize the term also referring to the first term of the series. So term is equal to x. Next, I told you that we can use a variable to denote the power as well as the factorial value. So I told you that variable is I, and initially I is equal to 1 because the power and the denominator of the first term is 1. So that is why we are mentioning I is equal to 1. Then we need a variable to fix up the error value. So let it be error is equal to 0.0001. So we need to generate successive terms. How do we generate? Increment I is equal to I plus 2 and term is equal to minus term into x divided by I into I minus 1 and sum is equal to sum plus term. All these things is derived from what we have observed from the series. So we have initialized I is equal to 1. So my next power and as well as the factorial is 3. Okay, so that is why I am incrementing by 2 because it is odd powers. So I am incrementing by 2 and I told you the generalized thing what we have observed is x squared divided by I into I minus 1 multiplied by the previous term. So we have mentioned as term this term refers to the previous term and this is your current term. And we have included this negative sign to alternate between the positive and the negative value. See, as you see, initially term is equal to x. Now when you substitute here, it will become minus x, which will turn the term into a negative value. And when you compute the third term, you will substitute this value as a negative value. So minus into minus, it will become plus. So it alternates between the plus and minus. Now once you compute the term, you have to add it to the sum. That's it. So you have to repeat these three steps as long as your term is greater than error. That's it. Now we can write from this logic your algorithm. So convert each and every process statement into an algorithm steps. So how do we write? So here the output will be in the variable that is sum. That is what you need to display. Now step 1. Step 2, you have to read the value of x. You initialize sum is equal to x and term is equal to x and we initialize I to 1 and we set the error value. These are the initializing steps. Okay, 3 to 6. Then from the 7th step, we'll just repeatedly do those 3 steps. That is, if term is greater than error, we will be repeating 8 to 10. So what is your 8th step? You will be computing I is equal to I plus 2. Then 9th step is you compute your term. 10th step is sum is equal to sum plus term. Okay. So after doing this, again it will come to 7th step and it will check whether term is greater than error. So if it is so, then it will continue with 8 to 10. If it is less than the error, it will go to the step 11, which leads to the termination. So it will display this sum and it will stop. So any algorithm you write, whether it works properly or not, can be verified. So let us see the verification of your algorithm. So when writing the verification, what you need to do is write down the steps. That is the step numbers of your algorithm, how it will be executed. And write down all the variables whichever is used in your algorithm and some checking what you need to do. So remember, when you are checking this term, you will be checking only the absolute of the term. Okay. So now, your second step, as you have seen, read the value of x. Okay. So I have taken as 0.5. And step 3 is initializing your, remember that algorithm steps. So step 3 is initializing sum. Step 4 is initializing term. And step 5 is initializing your I. Okay. So that's what is this one. And we have error also we have set up. And then we are checking whether your absolute of term is greater than error. So what do you mean by absolute? Even if you get negative, it will take the positive value. So yes, so 0.5 is greater than this. So what do you do? Now I will be incrementing I by 2. So it is 1. So it becomes 3. Then I will compute this term. How do I compute? It is minus term into x squared divided by I into I minus 1. Okay, so you get this value. And then you will add it with this. Okay, so remember these 3 steps will be repeatedly done as long as your absolute of term is greater than error. So once this computation is over, that is 8, 9, 10 are over, again it will go to the 7th step to check this condition. So it is yes, because when you take this absolute value, it will be 0.02. So it is greater than the error. So now what do? You repeat 8, 9, 10. Okay, so incrementing I by 2, computing the term and adding with the sum. Again, you go and check the seventh step. Okay, so if it is yes. Yes means repeat 8, 9, 10. Okay, once you do that, now look at the term. It is 10 power minus 6. Okay, so E means it is 10 to 10 power minus 6. So it is very lower value. So now this condition becomes false. So what happens? You have to go to 11th step. That is to display your sum. That's it. So having seen this computation of sine, you can also apply the same algorithm for the cos function with very minor correction. So let us see what is the change you need to do to obtain cos function. So what is your cos function? We have 1 minus x squared by 2 factorial plus x power 4 by 4 factorial minus x power 6 by 6 factorial. Now as you see, only difference between sin x and cos x is in the powers. There you have odd powers, here you are having the even powers. Now you can write this one as x power 0 divided by 0 factorial also. So that's what I have written here, x power 0 divided by 0 factorial. Now the same thing is applicable here by only changing this power. So remember, we observed the powers as well as the factorial. Here it follows a even sequence, and every term in the sequence can be referred as x power I by I factorial. Sign is also same here, alternating between the successive terms. So when you observe the relations, same relation exists. Okay, so you can see here, but only the I value is changing. There I started with 1 and I made this as 357. Now here you have to start with 0 and you have to make it as 246. But rest of the things are very much similar. So we write the current ith term as x squared by I into I minus 1 into previous term. The same formula is applicable here. Only thing we need to change is the power. That's it. Okay. So termination also we need to mention as we have seen. So I'll quickly dive into the logic and I'll tell you what is the change we need to do. So what change we are doing? Same variables and other things we are making. And look at here, we are making I is equal to 0. That is the power and the factorial value of the first term. Okay. So other things are similar. So when it becomes 0, the next ith term will be 2 and successively you will get 4, 6 like that. So this computation is very much same and you will get the output in the summation variable sum. That's it. So the algorithm is very similar. So what we need to do is we have to initialize I to 0. That's it. All other things are similar. So that is very easy. If you know the algorithm of one function, the similarity can be applied for the other functions also. Now I'll also tell you how you will solve other similar problems. So let us take sum of factorials. Okay. See, look at this series. So here we have 0 factorial plus 1 factorial plus 2 factorial up to n factorial. Here it is not an infinite series. Here you are limiting this up to n factorial where n is greater than or equal to 1. So now how do you solve this one? So again, observe what is the relation between the successive terms. So look at here. Now, I am observing the relation between the successive terms, and now I can also tell that as I told you, see here, look at here, 1 factorial is 1 into 0 factorial. 2 factorial is 2 into 1 factorial. That is, look at this previous terms, okay. 1 into 0 factorial, 2 into 1 factorial, that is your previous term, and 3 into 2 factorial. Now look at this I value. I value is initially 1, then it is incrementing to 2, then it is incrementing to 3. That means it is incrementing by 1 only at a time. So how do you generalize this? So you can write it as the current ith term is I, that is into previous term. That's it. So I into previous term. Now termination will reach when I reaches n. Okay, so you have to keep track of your I value starting with 0, and if it reaches n, you have to stop it. That's it. So the logic is you have to give what is your n value. That is your input. Now the process will be you same similar one only. You are using the sum to find out the summation of the series, and sum is equal to 1 because 0 factorial is the first term. So I am just making that value initializing to sum as well as my term. Okay, and then I will be using this I to refer the factorial of the first term, so it is I is equal to 0. So what do you do in the successive terms? You are incrementing I by 1. Okay, and then we found that term is equal to term into I. Here there is no alternate signs, everything is positive, so don't need to worry about sign change. So term into I, then you add it with the sum. So you have to repeat these steps as long as I is less than or equal to n. When I reaches n, when I become is equal to n, then you need to stop and print your sum. That's it. Now you can just transfer that into the algorithm. So you know I have explained you as before, you have to initialize and then you need to repeat. If I is less than or equal to n, you have to go here, compute I is equal to I plus 1. Those three functionalities. Term is equal to I into term, sum equal to sum plus term, and display your sum if this is equal to n. Okay, that's it. So you can also verify with an example. Now I am going to show you a very similar problem. It is also sum of factorials, but the representation is 1 by 0 factorial plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial. There you saw 0 factorial plus 1 factorial plus 2 factorial. Now this series is exponential series. So we need to compute this one. Now how do you do this? Now how do you express this, that is relation between the terms? That is what it matters, and it is also asked up to n terms. Okay. Now what is the relation and how will you explain? So first you take observation of between the relations. You take the second term. And how do I represent second term? It could be 1 by 1 into 0 factorial. So I can write it as 1 by 1 into 1 by 0 factorial, which becomes my previous term. Okay. Now similarly, I can write 1 by 2 into 1 by 1 factorial, which is my previous term. So you can look at the observations. So I as starts with 1 and then it goes to 2, 3. So it is incrementing by 1. Now what is this current ith term? How do I write? Current ith term is nothing but 1 by I into previous term. Okay, so 1 by I into previous term. That's it. So I have written 1 by I into previous term, and termination will reach when I is reaching n. That's it. That is simple. So logic is you have to input your n. Then other things are very similar, just to change this term. Okay, so term is equal to 1 by I into term. That's it. Okay, so it is that easy if you understand the logic of one particular sequence. A very similar sequence can be solved by just varying a very simple variables. That's it. Hope I have written the algorithm also. You can write same process. Term I initialization you are repeating, and compute I is equal to I plus 1, and you need to compute your term is equal to 1 by I into term. That's it. That is the change you need to do, and display your sum. That's it for this session. Hope you enjoyed it. Thank you for watching. Subscribe to my channel. to know the next upcoming videos. Thank you.